So for lesson 5, we're going to be looking at angle pairs and the relationships that angles have with each other and how that will help us to solve for unknowns, to actually solve for the measure of the angle, and to eventually make statements and prove statements about different geometric shapes. So that's kind of where we are going. So we have to lay the foundation for all of that first, and then we're going to be able to start doing what we call geometric proofs, which are taking statements and then listing all the reasons why we know that those are true statements. So this is kind of the baseline for all of that. So there is a lot of vocabulary because all of these angles have different relationships. So I want to make sure that we have them all down. Okay? So we'll start with adjacent angles. What does the word adjacent usually mean? Next to each other. So if we have adjacent angles, they are two coplanar angles that are next to each other, or they have a common side. So we would say two coplanar angles with a common side a common vertex, and no common interior points. So they don't overlap. Okay. So the way you can remember it is that adjacent means next to each other, so two angles that are next to each other. This is the full mathematical definition. So an example. Let's call this one angle 1, and let's call this one angle 2. So we would say that angle 1 is adjacent to angle 2. Because they are next to each other. They have a common side, which is this side right here, right? And they have a common vertex, which is that point right there. Yeah, that was my highlighter. Jonah, question. Okay, so interior points, going back to lesson 2? No, yesterday's lesson. So the very top of your notes from 7.4, interior points are the points within the angle. So interior points for angle 1 would be anything in here. Exterior points are outside the angle. So when it says they don't share any interior points, that means they don't overlap. So the angles cannot overlap. Good question. Other questions? Okay, so then let's talk about vertical angles. Vertical angles are my favorite angles. No, they're very easy to recognize. So vertical angles are two angles whose sides are opposite rays. So two angles whose sides
you're doing your rainbow. No.
I always do it like that.
Wait, that's red, orange, yellow, green. Well,
okay, so two angles whose sides are opposite rays. So that means, let's do this. So let's do 1, 2, 3, and 4. Okay, so the vertical angles are the angles whose sides are opposite rays. So if I'm looking at angle 1, the opposite rays of angle 1 are the sides of angle 2, right? because here's one ray and here's its opposite. Here's the second ray and there's its opposite. So the vertical angles are angles who are diagonal from each other. Okay, so it's very easy to see vertical angles because they are diagonals from each other. One thing I want to point out to you guys, if I added a fifth angle right here, are angle 1 and angle 2 now vertical angles? No, because not all their sides are opposite rays. Does that make sense? If I combined angle 1 and angle 5, they would be vertical to angle 2, right? But individually they are not. Make sense? Okay. I'm going to erase that though because I just like it like this. So angle 3 and angle 4, are those vertical angles? Yes. So vertical angles are the angles that are diagonal from each other, but to double check mathematically, you check that their sides are opposite rays, and both sides have to be opposite rays. Okay? Questions about that one? Okay. We are almost halfway there. Okay, complementary angles. Please notice that complementary is spelled different from complement, as in you look nice today. So in geometry, complementary means that they add up to 90 degrees. So two angles are complementary if they add up to 90 degrees. So two angles whose measures have a sum. You can say add up if you want.
I always do that.
Of 90. Okay. When we have complementary angles, and you guys can choose to write this or not, it's up to you, they are called the complement of each other. So each angle is called the complement of each other.
Is it really important to put it down?
No, but sometimes it's written out as like angle A is the complement of angle B. So you just have to know that that means they add up to 90. Okay. It won't always say angle A and angle B are complementary. So it kind of goes back and forth. Called the complement. Okay, so complementary angles are two angles that add up to 90 degrees. So if I have these two angles, and I have the little square that tells me it's 90 degrees, we would say angle 1 and angle 2 are complements. Sometimes the angles will not be right next to each other, but if you know their measures and you know that they add up to 90 degrees, they are still the complement of each other. Does that make sense? So complementary angles will not always be adjacent, although usually that is the case, but it does not always happen that way. So sometimes they're separated, and but you know the measures, so you can say that they're complements because you know they add up to 90. But they will not always be adjacent to each other, although this is what happens most of the time, which is why I used it as the example. So if we have a name for angles that add up to 90, and that's complementary, any guesses as to what supplementary is, Lily? 180. 100? Not 100, 180. So supplementary angles are two angles whose measures have a sum of 180. And then the same thing, they are called the supplement of each other. So each angle is called the supplement of the other. And like I said, that is optional if you want to write it or not. The supplement.
We're already almost done with this.
Okay, so remember, so it usually looks like this. So we would say 3 and 4 are supplements. Supplementary angles are a little different than complementary in that there is no notation that tells us something is a straight angle or a 180-degree angle. That is something you can assume. So if it is a straight angle, which you can tell just by looking at it, you can assume that they are supplementary. Okay? So there is no special notation like for 90 degrees for 180. It's just a straight angle, meaning a flat line. And then similarly to complementary, sometimes the angles might not be adjacent. They might be separated or they might be on different parts of a diagram. But as long as they add up to 180, they are supplementary. So they do not have to be adjacent to be supplementary. But 180 is one of those ones where you can look at the picture and say, that's a straight angle, that's 180, I can assume that. Sound good? Okay. Okay, so then we get into, those are kind of the big ones. We also have what's called a linear pair. And a linear pair is pretty much exactly what I was just talking about, where they add up to 180, but they are adjacent. So supplementary angles do not always have to be adjacent. Most of the times they are. And then they are also called linear pairs. Okay, so it's a more specific type of supplementary angle. So it is a pair of adjacent angles. A pair of adjacent angles whose non-common size are opposite rays. The angles of a linear pair form a straight angle. So basically, they are supplementary angles that are adjacent. AJ.
Doesn't a straight angle have like that half circle?
No. So the half circle is a way of representing that it's one angle altogether. So it doesn't always mean 180. We'll get there when we talk about congruent angles and stuff. So this one's going to be very similar to what we just did, but let's put some measures on it, or some, not measures, but some points. So here we would have angle ABD and angle CBD are also called a linear pair. Okay? So they are supplementary adjacent angles is what a linear pair is. Notice how AB and BC are opposite, or sorry, BA and BC are opposite rays, and they form a straight angle. So what AJ was asking is, doesn't this mean that it's 180? Not always. Sometimes, usually we use this when we're labeling it and we're saying, okay, that's 180. So the one arc means that when I'm measuring the whole thing together. We could similarly make two arcs if we want. Okay? So one arc does not always mean that it's 180, which is what you have seen before. Okay? So far, so good? Last one. And the last one is an angle bisector, which shouldn't be too bad because we have already done segment bisectors, right? So an angle bisector is specifically a ray. So remember, with a segment, it could be anything that goes through the midpoint. With an angle, it has to be a ray. that divides an angle into two congruent angles. Bless you. Okay, so a ray divides an angle into two congruent angles. So let's say I have an angle. Let's call it A, and we'll say X and Z are the points. There's only 26 to choose from.
I know, but like,
Well, the next one is going to be Y. So usually I like to use A, B, C, or X, Y, Z. But sometimes I'll use my initials or, I don't know, I just make it up. Sometimes I do it so they spell something out. Okay. So, we'll say that ray AY is the segment bisector. Now, just because they look congruent does not mean we can assume. So we have to make markings that show they are congruent. So remember with segments how we had the tick marks? And then if I were to make two more congruent segments, because we've already used one, we would have to use two, right? Yeah. Okay, same thing with angles. But we use arcs. So we would use a single arc if it's the first time, and a single arc on the other angle to show that they are congruent. If we have another set of angles that we are saying are congruent, we would use two arcs to show that they are congruent. Does that make sense? Yeah. Okay, so since this is the first one, we're going to use one. Especially with the arcs, especially if they're adjacent, try and offset them slightly so that they don't look like you're making one big arc around the whole thing. Because we do that sometimes too. When I'm trying to put the measure in, I will make a whole big arc to show that they're all going together. What I want to do for these is practice a little bit. So I'm going to give you statements, and I do have lines for you to explain, but for the sake of time, we're just going to say yes or no, and we'll talk about the explanations, but I'm not going to spend time writing them. Does that sound okay? It should be pretty obvious, but I'm trying to save us a little bit of time. So, the first statement says angle BFD. So that's this one right here, BFD. And angle CFD. So CFD. Let me use a different color. Are adjacent angles. Is that true or false? False.
I thought adjacent meant they were by each other.
Adjacent does mean they're next to each other, but they also cannot share any interior points. Angle CFD is inside of BFD, so they are not. So I would say false. They are not adjacent angles because they share interior points. That's the reason. Okay. Okay, so let me erase that, and we'll do the next one. Angle AFB, so that's this one, AFB, and EFD are vertical angles. True or false?
Oh my gosh.
Talk about it with your neighbor. Explain why. How many of you vote for true? How many vote for false? Good. This is a false statement. And I heard it best over here. FB and FE are not opposite rays. So they need to be completely opposite rays, and they are not. So opposite rays mean they go in the exact opposite direction. So they are not vertical angles. AFB. So then the next one is angle AFE. So AFE, ooh, that's off, and BFC are complementary. True or false?
I'm just gonna start listening to everyone else now.
What does complementary mean? Add up to 90. Okay. What's the measure of angle AFE?
62.
62 plus, what's the measure of BFC? Do those add up to 90? Yes. I'm worried. So it is true. So just because they are not adjacent does not mean they cannot be complementary. So they can be complementary. And I would actually take that and write it underneath the adding up the angles. Just because they are not adjacent does not mean they're not complementary. So you have to double check the angle measures. Okay, so then do the last one. BFC and DFE are supplementary. So we're going to have to do some adding. Supplementary means they add up to 180. So double check that for me. True or false? What do they add up to? 146? Okay, so they do not add up to 180. So that one is false. Everybody good? Yes? Okay. So remember how we talked about making assumptions and not making assumptions? I actually put it into a chart for you about assumptions we can make and assumptions we cannot make. So I would suggest that you know where this is and reference it if you ever get stuck. I just left it all typed out for you, but I want to go through it really quick. We can assume that angles are adjacent because they would be right next to each other, right? We can also assume angles are adjacent and supplementary because they're right next to each other and they will make a straight line. We can also assume angles are vertical angles. However, we cannot assume that angles or segments are congruent unless they are marked. So this means from an unmarked diagram. So if nothing is marked on it at all, we cannot assume anything is congruent. We cannot assume an angle is a right angle, which means we also cannot assume that angles are complementary if the diagram is not marked. If it is marked, we can make all the assumptions that the markings tell us are true. Does that make sense? So I mean an unmarked diagram, such as this one, although there is a little bit of markings here. So let's go through these really, really quick. From the diagram to the right, what angles can we assume are congruent? Definitely angles 1 and 2.
3 and 5, I think.
So we would say angle 1 is congruent to angle 2. Can we assume that angle 3 and angle 5 are congruent? No. But we can assume that they are what? Vertical. They are vertical angles. So angle 3 and angle 5 are vertical angles.
Oh, yeah, no, I know.
Okay, adjacent angles. There's a whole bunch. I'm just going to list like 1 or 2. So if I use angle 1, what angle is adjacent to angle 1? Angle 2. Or we could go the opposite way. What else is adjacent to angle 1? Angle 5, okay? So let's say angle 1 and angle 5 also. There are a whole bunch more. Basically, you go through all the angles in a circle. You just list the ones that are adjacent.
5 and 4.
What else is adjacent to angle 2? Angle 3. What else is adjacent to angle 3? And what else is adjacent to 4? And we already did 5 and 1, okay? You do not have to list all of them. That would take too much time. But let's do a couple adjacent supplementary. So adjacent and supplementary mean they add up to 180. What 2 angles do you see that are adjacent and they add up to 180? 5 and 4. Angle 5 and angle 4. Because they are right next to each other, and that's a straight line. There's one more. What's the other one? Adjacent only, so it means only 2 angles. Yeah, 3 and 4 also make up a straight angle. So then, Lily, that actually brings me to a really good point. She said, what about 1 and 2 and 3? Do all 3 of those make a straight angle? Yes, so we could say angle 1 plus angle 2 plus angle 3 equals 180. However, they're not adjacent, so that's not what the question was asking. But yes, we can also assume that 1, 2, and 3 make up 180 or a straight angle. Good. Okay? Okay, postulate 9, the linear pair postulate. So hopefully from the vocabulary, you thought adjacent angles and linear pair are very similar, right? It is a postulate. If 2 angles form a linear pair, they are supplementary. That should make sense, right? Okay, so if we have a linear pair, we can say that they add up to 180. So now we're actually going to start using the relationships to solve for the angles and to find missing pieces. So I give you the diagram in this one, and here's another thing that I want you guys to practice, especially on your homework tonight. Notice how on number 9 I give you the diagram, but on 10 and 11 I did not. It is your choice to draw a diagram or not on some of these problems. You do not always have to. However, sometimes it helps. So some people are visual and some are not as visual. So if it says that angle ADB and BCD are a linear pair, what I would recommend is drawing them and drawing them next to each other and then using that to help you figure out what goes where. However, if you are comfortable enough with a linear pair, means that they are also supplementary, you can go straight into the math without drawing the picture. Okay? For the first one, I give you the picture, so that's the one we're going to do. But if the picture is not there, always draw it if you need to. Okay, so KPL and angle JPL are a linear pair, which means they are also what?
Supplementary.
Good, supplementary. So I want to know, what are the measures of angle KPL and angle JPL? So guess what we're going to do? We're going to make an equation. So KPL is 2x plus 24. Let me zoom in. 2x plus 24. And if I add it to JPL, which is 4x plus 36, they should equal what? 180. Good. Okay, so we combine like terms. 2x plus 4x gives me 6x. 24 plus 36 gives me 60 equals 180. Subtract 60 from both sides. So I get 6x equals 120. And then divide by 6. So x equals 20. Did I finish the problem? No. I told you guys this already, right? I will say it again. This will be a distractor on a multiple choice question. What do we have to do to actually solve for the angles? Plug it in. So the measure of angle KPL equals. So since we're finding the measure of the angle with the numbers, we change our notation to measure of angle KPL, and then we plug it in. So 2 times 20 plus 24. So what do you get? 64 degrees. So since it's a measure, put degrees in there. And then we'll do the same thing for JPL. So the measure of angle JPL is 4 times 20 plus 36. So what do we get? 160? 116, yeah. Okay? Good.
On the test, is it okay after you put 64 to 27?
Great question. Rose said, could we have also, since we know they add up to 180, done 180 minus 64? Yeah, you can do that. Yep, there are multiple ways. As long as you are showing your work and I can see what you are doing, either way is fine. So, in our diagram, it says that ray GH bisects angle FGI, and they actually already indicated that for us by putting the little arcs. So, we know that those two angles are congruent. So I want to solve for the measure of angle FGH and X, and then we will find the measure of HGI and FGI as well. If these two angles, if GH is a bisector, what do we know about the two angles? They are congruent, or if we're talking about measures, we say they are equal, right? Okay. So, we set them equal to each other. So, 3x minus 3 equals 4x minus 14. I always like to keep x's positive, so I'm going to subtract 3x from both sides. Like I have said in the past, there are multiple ways of doing this. So if you decide to subtract 4x, you just have to make sure that you keep x negative, okay? So as long as you are showing your work and I can follow your work, you are fine. So that gives me negative 3 equals x minus 14. Add 14 plus 14. So we get x equals what? 11. Good. Now, did the question ask us to solve for x?
Yeah.
Yes. So I'm going to box it because that actually is an answer they were looking for. But what else does it want us to find?
The measure FGH.
Measure of angle FGH. Okay, so then the measure of angle FGH is 3x minus 3. So 3 times 11 minus 3. So that's 33 minus 3, which is 30. So guys, what's the measure of HGI?
30.
Also 30 degrees. So, what's the measure of angle FGI? The big angle. 30 plus 30, which is 60. Okay? What is one way that you can double check that we did all of our math correctly? You can add them up. We can also take X and plug it into HGI and make sure that it comes out to 30 as well. It should. And then we could also, then we would know for sure that we did everything correctly. So that's just a way to check your answer. Okay? Any questions or concerns about that?
Nope.
Sound easy?
Pretty much.
Okay.